we're gonna get technical. So, we've gone through some brainstorming sketches, we just played around with drawing a little bit, but now we're going to get into what engineers, designers use to actually bring specificity or specific details into their drawings. Because the whole idea of drawing is to convey information precisely so that it can be produced. Alright, so technical drawing. Accurate drawings that describe the exact size and shape of an object or product. Great. Let's get into our first one. Orthographic projections. That's a good word. Orthographic can actually be broken down into basic portions of a word, and this is a skill that I think you should try and work on over the course of your life. Identifying root words. So if you cut orthographic in half, you have ortho and graphic. Ortho kind of reminds you of like an orthodontist, somebody who puts braces on your teeth. Those braces make your teeth straight. Ortho literally translates to straight, and graphic translates to pictures. So orthographic, straight picture, projections. So to get started with this, first you need to identify an object. And here I have a three-dimensional version of myself. Now, just to get into 3 dimensions. In a 3-dimensional space, you have height, you have width, and you have depth. And these different sides of an object will show 2 dimensions at any time. When we have a 3-dimensional object like this, we want to locate the front view, the side views, and the top view. The front is red, the top is yellow, and the side is blue in this case. Now, this is going to burn into your head forever. But when you create an orthographic drawing, we then take this 3-dimensional object and we turn it into 3 2-dimensional pictures. So, you'll see 2 key things. Number 1, it's the pictures are positioned. The bottom left picture is the front view. The top view is if you take the object and you turn it so that you see the top. And going back to the front view, you want to make sure that you turn your object to face the front view. I think I'm mirrored, so I'm going to go like this. So your side view is going to be facing... Oh, wait a minute. No, that's right. Yeah, your front view is going to face the main object. So that's one key thing. The other key thing... Oh, I added a bunch of lines here. Okay, I'll just leave my... There we go. These lines show the dimensions that are shared. So my front view, in my front view, I can see the height of my face and the width of my face. That height can also be seen in the side view, and I line these up very specifically. So my front view has a height, my side view has the height, and they're lined up. My front view also shows width. You can see how wide my face is. So when you have that width showing, and you line it up, you can actually match it to the top view of your object. Depth. Depth is a little more tricky because it's shared between the side view and the top view. You can see how deep my head goes. It goes how far back my head is going in these pictures. And that dimension is shared in the top and the side views. Now, one common mistake I see with my students, they will take an object, okay, they draw a front view, then they draw a side view, and then they think, oh, I'll do a top view, and then they draw the top view like this over the front view. But when my head is turned this way, it actually doesn't match the width. So that's a common mistake. Now, here's a picture of an old video game controller. This is a Nintendo 64 controller, and it shows you how cleanly you can portray or show an object when you use orthographic views. Here is our front view, and if you were to just focus on the front, top, and side, okay, we have our front view here, and then you turn it so you can see the top, but it's lined up on the right side and the left side. Now from the front view, you can turn it to make a side view, or the right view. Here we have the joystick lined up with the other joystick in the front view. It's also facing the front view. Now, you can also continue turning your object and do different views of it. But pretty much every object that we own has a picture of it like this somewhere in the world. Somebody took time to plan and measure out all the specific dimensions, and then they conveyed it clearly so it could be produced, made, or manufactured. Alright, so my task for you, okay, just after you do your measurement quiz and you watch this video, you are going to be drawing a tissue box with an orthographic projection. I want a front view, I want a side view, and I want a top view. At this point you can attempt it yourself, but I'm going to continue this video with a view that you can see exactly what I'm doing. Alright, so first thing you'll notice is that I set up my paper in what's called a landscape orientation. This is common for drawing orthographic projections. Secondly, I've got graphing paper because that grid is going to help me line up my different drawings. Remember, you can do this for support. This bottom left is my front, the top left is my top, and then the bottom right is my side view. Now, to help me with this, I diagrammed a three-dimensional isometric picture of the tissue box with some basic dimensions. We're not really getting into dimensions just yet because orthographic drawings are new. I don't think it makes sense for us to really, do everything at once. So, I'm going to start with my front view. Now, when we look at a three-dimensional object like this, if you go back to in the video to my face, this is my front, this is my side, and this is my top. So I'm going to start with my front view. I'm going to get my straight edge out because we want to make this nice and clean. I'm going to start with the width. The width is 4 inches. I'm going to make every box on my page an inch. We're going to get into scale later, but that's the width. Now I need the height. The height will be 4. And I'm going to do the right side as well because it's a square. Now that I have my front view, this is where we got to pay attention. I'm going to do my side view. Now, I know that it shares the same height. The box is the same height. I mean, let's see. The side of it, or the front of it, and the side of it are going to be the same height. It's the same object. So when I do my side view, since I measured out the height of the front view, I can just take a straight edge and line it up. I'm going to put little dots, 1. And I can copy my height using that straight edge. So here I indicated with 2 dots, and I'm going to do the left side of my side view. So that's the height of the side. This line matches up to this line. Now my depth is 8. So I'm going to count out my boxes. 1, 2, 3, 4. 1, 2, 3, 4. Boom. I'm going to do the same down here. 1, 2, 4. 1, 2, 3, 4. And I'm just going to connect the dots. Now, in my top view, I'm going to imagine the box like this for my front and turn it for my top view. The width of the top is the same as the width of the front. So I'm going to just put dots that match up. And I'm going to count out 8 boxes. 1, 2, 3, 4. 1, 2, 3, 4. Great. Also, for a straight edge, you can use anything that's straight. Ruler, here I've got a 30, 60, 90 triangle. You could use a credit card or something. But the last part of this, I noticed that there's actually an edge of the cardboard. It's a giant rectangle on my page. So what I'm going to do is I'm going to include this by making a rectangle in here that is offset or put in one box in every dimension. If I want to get really fancy, here's the cut in the plastic. Now, going along with getting fancy, you could include the tissue in the front view. And I'm not going to ask you to do this. This would be all you need to bring to class tomorrow. But if you wanted to do the tissue, it could be, well, you should use a straight edge. I'm just estimating here. Like I said, this is just to get the idea. There's the front view of the tissue, and my side view is going to be the same exact height. So I'm going to just line that up. It's going to be here. I'm going to make it just about this. Boom. Key things with this. The width is matched up. The height is matched between the front and the side, and the depth is matched between the top and side views. Alright. Save this, you'll submit it tomorrow, and have a wonderful day.